Hello. What we're going to look at right now are these kinds of problems that involve speed, distance, and time. And these can be fairly straightforward problems if you follow what I'm going to show you here, setting up all the information given in the problem in a table. But before we go ahead and do an example, I want to refresh your memory on this little relationship, speed or velocity, distance, and time. You may have seen this little triangle before, and it shows you the relationship between speed or velocity, distance, and time, and allows you to very easily create three different equations. One of them is that speed or velocity equals distance divided by time. And if you think about it, you take any speed that we use in everyday occurrences, 80 kilometers per hour. Well, 80 is the speed, kilometers per hour. Distance is kilometers, hour is time. So, I mean, very easy to keep clear which one's which if you think of everyday examples. But another equation is time would equal distance divided by the speed or velocity. And the last one that is probably the most useful because it doesn't involve fractions is that distance equals the velocity or speed times the time. So this tends to be the one I like to use the most frequently because of no fractions. Okay, let me do an example of a question like this. In this example, somebody has driven 550 kilometers in total, and part of it was driven on the highway. So part on the highway, and the speed driven on the highway, we'll just make a note here, it was 110 kilometers per hour. And the rest of the trip was done on side roads. So rest on side roads. And of course, on side roads, you can't go quite as fast. They averaged about 45 kilometers per hour on side roads. The total trip took 8 hours. And of course, what's the question now? Well, how far did this person drive on each of these different types of roads? How many kilometers were driven on highway? How many kilometers driven on side roads? So that's what we're trying to figure out. How many kilometers driven on each type of road? Okay, what you want to do is take all the information given and write that into some kind of a table. Now I'm going to have to erase this, so I've got room for a table here, but hopefully you've got that written down on a piece of paper in front of you. So let's get rid of this. And the way this table is going to look is you start off and say, well, there's a speed, there's a distance, and there's a time. And we have two different situations here, highway and side roads. Okay, so that's basically the table. All we got to do now is fill it in. We know that the speed on the highway was 110 and the speed on the side roads was 45. The distance, well, we know that the distance covered was a total, I'll put kind of a total thing on the bottom here. The total distance covered was 555 kilometers. And we know the total time needed for the trip was 8 hours. Now everything else is left empty. We don't have any information there. So now what we have to do is start putting some variables in. Ultimately, it's probably wise to plan this to use variables that will answer the question that was posed. And the question posed was not how much time was spent on each of the different types of roads, but what distance was covered. So I'm going to put x and y in for distances. Now, what do I put in for time? This is where our little triangle comes in handy. And we think, well, time is just distance divided by speed. So distance divided by speed is what my time is. So x divided by 110. And for this one, it's y divided by 45. Well, now I've got my table filled in. I only have two unknowns. So all I've got to do is create a couple of equations, and then hopefully I can solve those with the minimum amount of work. Well, one equation is quite easy, that this distance x plus this distance y must total 555. And another equation is, well, we've got total time here. So I've got x divided by 110 plus y divided by 45 equals 8. This is my system of equations. All I have to do now is go ahead and use a technique to solve that system. Now my suggestion would be, top equation looks great, the bottom one has a bunch of fraction stuff in it, so I'm going to clean that up. I'm going to start by multiplying everything by 110, and so I'll give myself a little bit of room here for the cleanup. Keep my two equations, and the top equation is good. This one I'm going to start off and multiply everything by 110. So it's 110 times x over 110 and y over 45, equals 8. So here's what I have to do. Well, why did I pick 110? Because it cancels. So this is just going to be x plus. Now this is going to be a little ugly. I got 110 times y, still over 45. And I got 8 times 110, which is 880. Now that's a little bit of an improvement, but not good enough. So now I'm going to multiply everything by 45. Why 45? Because then this will cancel. So I'm left with 45x plus, now it cancels, 110 times y. And this one I'm going to do on the calculator. 45 times 880 is 39,600. So now I have two equations. This one, which is a lot nicer than the one with the fractions, and then the x plus y equals 555. To get something to eliminate, the least amount of work that I have ahead of me is to just take this one here, the x plus y, and multiply that by negative 45. So I'm going to write that right underneath here. Negative 45 times x, negative 45 times y, and negative 45 times 555. So that's negative 24,975. I'm going to take those two equations and add them up. So the x's will cancel. I've got 110 minus 45. And over here we've got 39,600 minus 24,975. And that's 14,625. We'll divide by 65 to get our answer. So this turns out to be 225, and y, if you recall, if you look back at the table, was the variable for the distance on side roads. So we might put that answer over here. Side roads was a distance of 225, and for highways, remember that they had to total 555. And so I'm going to use this equation and say, well, I know that the y value is 225, so I'd go 555 minus 225 to get the highway driving. And that turns out to be 330 kilometers. So that's a finished example now with speed, distance, and time. I'll just tell you one more little hint about speed, distance, and time. Sometimes the questions talk about winds or currents. And I'll just do a very simple one. I won't finish this example. I'm just going to illustrate how to set it up. Suppose you had a problem where you were flying with a plane and you took 4 hours to fly, say 4 hours into the wind. Now that basically means a headwind or against the wind, so known as a headwind. And perhaps it only took 3 hours to fly with the wind, what they call a tailwind. When you set this up, you're going to have something along the lines of this: speed, and of course your distance and your time. But all I'm worried about now is to look at speed. If we don't know what the plane speed is, let's call it x. If you're flying with the wind is pushing the plane, it's helping the plane. So this would be the plane speed plus the wind speed. So this is the headwind, or sorry, the tailwind. If you're talking about the headwind, then you're talking about losing the speed of the wind. So it's the plane speed take away the wind pushing against the plane. And for the rest of it, you would simply put in whatever distance was covered or whatever amount of time was taken, and you would work out your equations just like we did in the previous example. So that's a little tip there to help you with some of the wind problems, or current if it's a ship. I'm going to stop there.